Hello dear friends, in trick number 412, I am going to continue my series of videos on finding the total number of triangles and total number of squares in a given figure. Now see, these are some of the figures which are very commonly asked in competitive exams, and you are asked to find the total number of squares in these figures. So I'm going to tell you a shortcut through which you will be able to count these squares without actually counting them. So this is going to help you a lot in competitions. Now see, this is the first kind of figure in which the number of rows and the number of columns are same. So whenever we have the number of rows and columns same, then things are very simple. Now see, in the bottom row you have only two squares here, whereas in this figure you have 1, 2, 3, 4 squares and 4 in the column also. So these are of the same type, and once you know the problem is of this particular type, then applying the shortcut will take you only 2 or 3 seconds to solve this question without counting the squares. Now how do you do this? You have to write the squares of these four numbers. See, 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16. So just write the squares of all the numbers you have written in the bottom row and just add them. So 16 plus 9 is 25 plus 5 is 30. So that gives you your answer. The number of squares in this figure is 30. Likewise, if you have, now you can solve this very easily. 1 square is 1, 2 square is 4. So the total number of squares in this figure is 5. Very obvious, 1, 2, 3, 4, and the larger square, that is the fifth square. Now see this case. In this case, the rows contain different number of squares as compared to the column. So here the method slightly changes. Now I'm going to tell you a shortcut through which you can find the number of squares in this figure also without actually counting the squares. Now in this case, once you write 1, 2, 3, 4, 5, 6, so you have 6 squares in the bottom row, and if you start writing like this vertically 1, 2, 3, 4, so you have 4. So just multiply these two numbers, you get 24. And now what you do is you keep on reducing these two numbers by 1. So 6 becomes 5, 4 becomes 3, so this becomes 15. Keep on reducing this until you get a product 0. So 5 becomes 4, 3 becomes 2, 8, 3, 1, 3. So now if you do it one more time, this will become 2, but this will become 0. So no more further combinations are possible. So just add the numbers which are obtained here. This is 39, 49 and 50. So 30, 39 and 11, 50. So the total number of squares in this figure are 50. So friends, you have learned a trick through which you can find the number of squares in two kinds of figures. The first case where the number of squares in the columns and number of squares in the rows are equal. So you can apply the formula that you have to find the sum of the squares of the numbers written in the bottom row. And when the number of squares in vertical and horizontal columns are different, then just write the two numbers and multiply them and keep on reducing it by 1 and multiplying till you get a product 0, and then add all the products which you obtain. You count the total number of squares as 50 squares accurately in this. Now see, whenever you have such problems, you need to be aware of the basics. So in this figure, you see there are 3 squares inside one another. So whenever you have a figure like this, one square with a vertical line and a horizontal line dividing the larger square into 4 parts, 4 smaller squares, then there are 1, 2, 3, 4 and the larger square, that is 5 squares in all. So if we consider the inner square, the innermost square, so it is divided into 4 smaller squares. So for this shaded portion, you have 5 squares like this. So 5 squares for the shaded portion. Then if you consider the next square, which is the second one, which is the intermediate between the outer and the inner square. Then again it is divided into four parts. So this is 1, 2, 3 and 4 squares and the larger square. So 5 more, and finally we have the largest square, again divided into 4 smaller squares by the horizontal and the vertical line. So 5 more squares. So you have 15 squares in total. So don't need to actually count the squares. Just by looking at the figure you can tell how many squares are there in this figure. Likewise, see, we have one more figure here in which we have a number of smaller squares, but if you again count the 1 2 3 4 5 6 like this, you are bound to miss some of the squares. So you need to be aware of the shortcut method here. So you just see the square which I am darkening right now, this one. So if you consider this, this is actually a 3 by 3 matrix. So 1, 2, 3 and 1, 2, 3. So if you consider only this much, the shaded portion, then you need to know the shortcut for finding the number of squares contained in this 3 by 3 matrix. So how do you find it? This is 1 square plus 2 square plus 3 square. So whenever there are equal number of squares along the length and along the breadth, then you have to just name one of the lines and just square them and add them. So this will become 9 plus 4, 13 plus 1, 14, and you have 1, 2, 3, 4 squares left out. So plus 4. So in all you have 18 squares in this figure. So let us try and understand this figure to count the total number of squares. Now see, whenever we have a larger square divided into horizontal and vertical lines, see here we have 3 horizontal lines and 3 vertical lines which are drawn in this figure, then we have a definite number of squares along the length and definite number of squares along the breadth. Now see, here we have 4 squares along the length and 4 squares along the breadth. So whenever there are equal number of squares along the length and breadth, then the problem is very simple. And this problem can be asked, suppose we don't have this first row, then in this figure also we can be asked to find the total number of squares. That will be a different method. So consider this 4 by 4 matrix having these 16 squares. So if you count 1, 2, 3, 4 along the length or along the breadth, because they are same, then the total number of squares in this large square is 1 square plus 2 square plus 3 square plus 4 square. So in turn, this will give you a total of say 16 plus 9 25 plus 4 29 plus 1 30. So there are 30 squares in the larger square when you consider only the horizontal and vertical lines. But now we have lines along the diagonals also. So see, there are number of lines drawn like this and number of lines drawn like this. So now you need to consider another square which is at 45-degree angle. Now I am marking the vertices of that square which I am considering now. So look at these 4 vertices which I have darkened right now. If you see this square like this, now again 1, 2, 3, 4 and 1, 2, 3, 4. It is similar to the figure which is originally given to you. So if you consider only this much, then the squares which we are counting here, these squares we have not counted in these 30 squares. So 1, 2, 3, 4, 1, 2, 3, 4. So another figure of that kind. So that means we have to repeat this process and we have 30 more squares made from this square which uh, of which the vertices I have darkened right now. Now what are we left with? We are left with one square, this one. See, we have not counted this either in the larger square or in the smaller square. So parallel to this we have this second square. We have not counted this also. Third, fourth, fifth, sixth, and similarly here seventh and eighth. So these eight we have not counted yet. So eight more, and still we are left with four more squares, because if you combine this shaded area with these two squares, then we have one more square. See, and now I am shading the one which I am counting now. So this is the square which we have not counted. Similar to this, if you shade these two also, then you have this square, here also this square, and here also this square. So now we have four more squares. Now we have completed all the squares in this, and the resulting answer to this question is 72 squares. So students, you see, we need little bit of understanding. Obviously there is a trick when you have to find out the total number of triangles consisted in this larger square and made by the vertical and horizontal lines. How to find those total number of squares 30, because if you keep on counting those 30 triangles, you will lose a lot of time in given figures. Two more very important questions. Now this is the first question which I am taking up. Now see, here you can see a large square which is divided by vertical lines and horizontal lines into a matrix of 4 by 4. See, 4 small squares in the rows and 4 small squares along the breadth. So there are actually 16 small squares in the large square. That is if you don't consider this one. So we are not considering these 4 squares right now. We are just considering only 4 by 4 matrix which is in the larger square. So what happens when we have such a matrix? We can easily count the total number of squares in such a matrix by just counting the number of squares along the row and taking their squares. So 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16, and we add all the squares to get the total number of squares in the matrix. So this is 25 plus 5, 30. So we have 30 squares in the large matrix, but now this is incomplete. Now we have to consider the small square. Now if you see the small square, this is 1 square, and inside it you find 1, 2, 3, 4, 4 squares. So whenever a small square is divided into 4 parts, there are 5 squares. So 5 squares here, similarly 1, 2, 3, 4 and 5 squares here, 1, 2, 3, 4 and 5 squares here, and 1, 2, 3, 4 and 5 squares here. So 5 plus 5 plus 5 plus 5. So we have 30 plus 20 more squares, so which gives us a total of 50 squares in this figure. So I hope you have understood that 50 squares in this figure. Now take this figure. Here also we have the same kind of matrix. So let us count the number of squares in this matrix first. See, here we have 1, 2, 3, 4 squares along the length and 1, 2, 3 squares along the breadth. So whenever we have different number of squares along the length and breadth, then the process changes. Here we have taken the squares of the numbers because the number of squares along the length and breadth were same, but here they are different. So what we do is, this is a 4 by 3 matrix. So 4 into 3, then reduce this by 1, reduce this by 1, 3 into 2, then again reduce this by 1 and reduce this by 1, 2 into 1. Now we cannot reduce it further because this will become 0. So add all these products, this will become 12 plus 6 plus 2. So 12 plus 6, 18 plus 2, 20. So we have 20 squares in this large matrix. Now what about remaining squares? Now see, if you observe carefully, we have one square whose vertices I am just marking. Now see, this is one square, a large square, and this is another square, and this is another square. Apart from these three squares, the one larger one and two small ones, there are no other squares which are left uncounted. All the horizontal and vertical lines have already been counted. So these 12 and these squares all are already taken account of in this 20 squares. So only these two small squares and one large square remains. So gives us three more squares. So add 3 to this, you get your final answer for this question, that is 23 squares in this figure. So friends, I hope you have understood the basic process through which we are counting the squares, because traditional method will consume a lot of time and also give you a rough estimate only. Having an exact estimate requires the use of these kind of shortcuts to come out successfully in competitive exams. So I hope you like the video, and if you do, share it and subscribe the channel.